Welcome all. In today's class, I'll be discussing all about Coriolis component of acceleration. When is this acceleration coming? And we'll be seeing a practical like with the help of models. So I have made some models. So these are the models and I'll be explaining beautifully how that with two models I'm going to explain beautifully. So if you want to learn completely, please stay till the end. I'm not forcing you. Let me repeat. I'm not forcing you. If you want to learn, stay till the end. Otherwise, there is no problem. You can leave and please no problem at all. So let us observe clearly. This, what is happening? Let us see. Let us take a link. Let it be rotating at a angular velocity omega. And you know, my dear students, so take one point. Let us assume it is rotating. It is under pure rotation. Okay. So after some time, let it reach this position. So is there any change in the radius? No. This is R, this is R. Let this be point P, the same point after some time it is here. Let us assume that this omega is changing. Assume omega is changing. It need not be constant. It need not be constant. It may be variable omega also. Look at now. At this instant, let omega be the angular velocity. So therefore, the tangential velocity is given by, and you know that the tangential velocity is always perpendicular to the line joining the point of rotation and the point under consideration, and that is r omega. So at this point, it is r omega. Now let us see what is the tangential velocity at this point, and definitely it will be perpendicular to this. It will be perpendicular to this. To this link, it will be perpendicular, and this point is at the same radius, so it will be r. I don't know what is omega. Please listen carefully. Let the new value of omega be omega plus d omega. Excellent. Now, my dear students, understand carefully. So this is the initial point. This is the initial point velocity, that is r omega. And the final velocity is like this. It is r into omega plus d omega. And you know, to this line, this is perpendicular. And you know, to this line, horizontal is perpendicular. So if you turn this just 90 degree, you will get the same angle. So if this angle is d theta, this will also be d theta. Let me repeat, sirs. To this line, this is perpendicular. To vertical, horizontal is perpendicular. So this will be your angle d theta. Excellent, sirs. Excellent. Now let me resolve this into two components. One is like this, one is like this. And this is r omega plus d omega. It will be r omega plus d omega, and it is opposite. It is sine d theta. And this is r. I'm resolving this into two components. That is r into omega plus dr. It is opposite is sine, and this is cos d theta. Let us see what is the change in velocity in the tangential direction. I am considering changes always with respect to initial. With respect to initial, this is the tangential direction and this is the radial. Let me repeat. So with respect to initial, this is the tangential, this is the radial. So let us try to find out what is the change in velocity in the tangential direction. Change is final minus initial. The final tangential velocity is this, and the initial tangential velocity is this. So therefore, r into omega plus dr, and you know cos d theta. So cos d theta minus, this is final, minus initial, that is r omega. Excellent. So the tangential, the change in the velocity in the tangential direction is, and you know, we have taken small d theta. So small d theta means cos of small angle is 1 only. So therefore cos 0 is 1. This d theta is tending to 0. So therefore this is 1. So r into omega plus dr minus r omega. So therefore the change in velocity in the tangential direction is given by r omega plus r d. What is this? This is r d omega. I'm sorry. This is d omega. This is d omega. This is d omega. Okay, d omega. No problem. Minus r omega. So this is gone. So the change in velocity in the tangential direction is given by r d omega. I want the acceleration in the tangential direction. So rate of change of velocity, that is, this is equal to, you know, now you divide both sides with time. So therefore tangential acceleration is change in velocity by time. So change in velocity by time. So therefore I am dividing with dt. So therefore d omega by dt. And you know, change in angular velocity per unit time, rate of change of angular velocity is angular acceleration. This is our alpha. So therefore at is equal to r alpha. The tangential acceleration, the acceleration in the tangential direction, when the link is rotating, the tangential acceleration is given by r alpha. If it rotates with uniform angular velocity, so there will not be any change in omega, this will be 0. So therefore r into 0, the tangential acceleration will be 0 if it is rotating at uniform omega. Leave it. Let us see the second part, r omega. This is first I am taking the simple case because you should have a better understanding. Now, dear students, let us take a link like this. And now you know this is r omega, initial position, and this is r into omega plus d omega, because I am taking about the same position, same point is rotating like this. So let me resolve. If this angle is d theta, this will also be d theta. So I will resolve this. Now look at, we have already seen the tangential. Now we'll see in the normal or radial direction. With respect to initial, this we call it as normal or radial direction. Is there any initial velocity in this direction? Initially it is vertical and entire velocity is in the horizontal or tangential direction. There is no component in the radial or normal direction, which we call it as centripetal. So therefore, now let me resolve this. So this will be r into omega plus d omega, opposite is the sine d theta. What will be the change? Final minus initial. So this is the final velocity in the normal or radial direction, and initially there is no normal velocity in the radial direction. So change in velocity in the radial direction, or it is also known as normal direction, is given by r omega plus d omega sine d theta. Okay, change is final minus initial. This is final and initially 0, but I put minus. Why minus? Because in the downward direction. Downward means in the downward ka matlab kya hai? In the decreasing radius. So therefore I put minus. No problem at all. So therefore it will be d theta is very small. Sine d theta will be d theta. So minus r omega plus d omega. This will be d theta. So therefore dvn will be equal to minus r omega d theta minus r omega d theta plus this is also minus, let me erase this, right. So the change in velocity in the normal or radial direction, this is also radial direction, is given by minus r omega d theta, correct, minus plus into minus r d omega d theta. Everyone knows this d theta and d omega are very small. So product of two small quantity, for example 0.2 into 0.1, it is 0.02. So this is very small and neglected. So product of two small quantities very small, neglected. So therefore the velocity, the change in velocity is given by r omega d theta. Exactly. Now I want acceleration. What is the acceleration in the normal direction? So divide with time. So therefore I'll write this acceleration in the normal direction as minus r omega. What is change in angle? Rate of change of angle omega. So into omega. So acceleration in the normal direction is minus omega square r. It means whenever a member is rotating, there is a tangential acceleration of r alpha, and there is a normal acceleration of omega square r, and this normal is always directed towards the center, which we call it as centripetal acceleration or normal acceleration or radial acceleration omega square r. This is for pure rotation. For example, I'll take this. Just take this. For example, focus on the red link. This is just rotating. Focus on the red link. It is just rotating. So I have talked about this rotation. Now there are some situations. There is sliding and rotation. There are some situations where you have both sliding and rotation. Dekho, you might have seen in crank and slotted lever mechanism. Let's see what is happening. And for example, if a member is sliding like this, pure sliding, so the acceleration will be either in the positive x direction or in the negative x direction. But you have no acceleration in this direction. So for example, if the member, let us assume this to be a fixed member, and on this fixed member, this slider is sliding either in the upward or downward direction. So in this case, acceleration will be only in the either plus y direction or minus y direction, no other acceleration, because this is not rotating, it is just sliding. But now let us see there is no problem in pure sliding Pure sliding acceleration either will be in the plus y direction or minus y direction, depending on what whether the velocity is increasing or decreasing in plus y direction. So if it is rotating, there will be tangential and there will be, why there is a normal acceleration? The reason is, dear students, the reason is why there is a normal acceleration. The reason is there is a change in direction. There is a change in direction. So you observe here, if the member is just rotating with constant angular velocity, let me tell you, just now I said it has a tangential acceleration and it has a radial acceleration omega square r. So let us suppose this link is rotating with constant omega, and alpha is equal to d omega by dt. If this rotates at constant omega, there is no change in omega, this will be 0, alpha is 0, tangential acceleration is 0. So in case of the link rotating with constant angular velocity, there will be only centripetal or radial or normal acceleration, because if you see, the direction of velocity is changing. Now these are all easy, sirs. Now the complicated case is simultaneous sliding and rotation. Why I have given all this is you will have a better understanding. Let me show you this. Just focus on, dear students, just focus on this link, this one. Now look at. This is sliding and rotating also. This is sliding. देखो एक बार ये slider देखना. You just see, my dear students, it is sliding and rotating. This is sliding and rotating. Great. Let us see simultaneous rotation and sliding. I repeat, simultaneous sliding and rotation. And I will try my level best to show you the beauty with beautiful models. So this is the initial situation. There is a point. Please note down that with respect to this vertical link, the slider is sliding. Now understand, this is the initial situation. Let us take this as some point. This is origin, and let this link be rotating at omega. And please note down that, let me take a complicated case. What do you mean by complicated case? This slider is moving at different velocities, different sliding velocities. At one instant, the sliding velocity was, let us say, some v, and after some time it is v plus dv. And let us say this link is initial angular velocity is, let us say, 5 radian per second. After some time it is 7 radian. Let us complicate the situation. Then only we'll be in a better position to understand. So this is initial. So let this radius be r. And initially this link is rotating at omega. So the tangential velocity is given by r omega. And let us suppose this slider is sliding. Ek second. We'll take different color. Okay. Let us suppose this slider is sliding. Let us suppose this slider is sliding in this direction. Let v be the velocity of slider. No problem at all. My dear students, let v be the velocity of slider. At this instant. After some time, let us assume that this point, in previous case, the point was at the same radius. Let this point move outwards. It may be moving outwards or inwards. Let us take outwards. So now the point has moved outwards. So iska matlab, for example, if this radius is r, let this be dr. So now the new radius is, with respect to this point, r plus dr. So what will be the tangential velocity, my dear students? Let us assume that at this instant, my omega of this link, vertical link, has become omega plus d omega. At this instant, so what will be the velocity? R omega. My r is, of this point I'm taking, my r is r plus dr, no more r, because it has shifted r plus dr into omega. Now what is new omega? Omega plus d omega. So actually the tangential velocity is r omega. So my r is r plus dr, my omega is, let us take all complicated cases, omega plus d omega. Now, dear students, the slider is also sliding. At this instant, let us suppose, let the velocity be v plus dv, because it is along this, it is sliding along this. Let v plus dv be the velocity of sliding. Please note down that this sliding is with respect to this link, this link. So therefore it is sliding. The sliding is with respect to this link. You should be very, very careful now. And you know very well, dear students, अब देखेंगे पूरा beautifully, will try to open up everything. And what will be this angle, sirs? Already this is the same straight line. Vertical, let it be d theta. Same straight line, vertical. So this will be d theta. And to this line, this is perpendicular. And to vertical, horizontal is perpendicular. So this will be d theta. To this is perpendicular. To vertical, horizontal is perpendicular. You just tilt this, you'll get this only. Now, let us try to find out what is the change in velocity in the tangential direction. What do we mean by tangential? Change is always with respect to initial. Initially, the link is like this. This is the tangential direction. So with respect to this, let us find out the change in the velocity in the tangential direction. So dear students, if you observe clearly, so I am writing this. What is this? R plus dr into omega plus d omega. Okay. Now this angle is d theta. I want this in the tangential direction. Opposite, this will be sine and this will be cos. So therefore this will be r plus dr into omega plus d omega, and opposite is sine, this will be cos d theta. Exactly. So we have found the component of this velocity in the tangential direction. With tangential means here with respect to original. Similarly, this velocity, what is this velocity? V plus dv, and the vertical is angle theta, d theta. Now I want in the tangential direction, what is the value? V plus dv, it is opposite, so therefore it will be sine d theta. Observe here, what is the total tangential component of velocity? Finally, this is final and this is initial. Don't say final means it's fine, it's moving continuously. With respect to this, I am talking about this. So there is a component of this in the rightward, that is tangential direction. There is a component of this in this direction, and both you add, that will give me the total tangential component finally. So add, so therefore, so r plus dr, omega plus d omega, and you know cos d theta. D theta is very small, cos of small angle will be 1 only, so I am not writing, this will be 1. So into 1, this will be 1, I am not writing, plus this value, this value, this value, v plus dv into sine d theta. When d theta is very small, sine d theta will be d theta. This is the final tangential velocity, component velocity. What is the change? It is final minus initial, and initial is r omega. So therefore the change in velocity in the tangential direction is final minus initial. So therefore we are calculating the change of velocity in the tangential direction, that is r plus dr, omega plus d omega, plus v plus dv d theta minus final minus r omega. Absolutely fine. No problem at all. Absolutely fine. Absolutely fine, my dear students. Absolutely fine. Ab dekho, let us simplify. So this is the case of simultaneous rotation and sliding. Dekho, r into omega plus omega dr. I'm just simplifying. R into omega, omega dr plus r omega. R into, already we have written, r into omega, r into omega plus omega into dr, okay, plus r omega, ये होगा r d omega plus dr d omega plus v d theta plus dv d theta minus r omega. Wait, r omega is gone, and you know dr is very small, d omega is very small, the product of two small quantities is very small, dv is very small, d theta is very small, product of two quantities is very small. So the change in velocity in the tangential direction is given by omega dr plus r d omega plus v d theta. Now I want the acceleration of simultaneous rotation and sliding in the tangential direction. So if you want acceleration in the tangential direction, what will be this? So change in velocity by time. So I got change in velocity in the tangential direction, divide with time, divide with time, divide with time, divide with time. Wait. So the tangential acceleration for simultaneous rotation and sliding is given by, what is dr by d theta? And please note down that the beauty is here. Dr by d theta means it is moving with respect to this link, it is moving radially outwards. With respect to this link, it is moving radially outward. So original velocity, original radius was r, new radius is dr. Dr by d theta is showing velocity of sliding, sliding of this slider with respect to this link. So originally, look at, originally it was some, 1 second please, originally it was somewhere here, at the radius r. After some time it is here, so it is sliding, and this is showing what is dr. So I repeat, sirs, originally it was somewhere here at this radius, now after some time this is, dekho, it is here, so this is dr, means dr is showing what? Change in the radial distance with respect to time, means it is showing the velocity in this direction, and that is known as velocity of sliding. Who is sliding? The slider is sliding with respect to this link, so omega dr by dt is velocity of sliding. I write v is velocity of sliding plus r. What is d omega by dt? And you know very well, d omega by dt is alpha, rate of change of angular velocity is alpha, plus v. What is d theta by dt? Omega. What is rate of change of angle? Omega. Oh my god, we have seen that in case of pure rotation only r alpha. That was the reason for deriving that equation, pure rotation. In pure rotation we have seen only r alpha, but now I am seeing something v omega. V is velocity of sliding and omega is the angular velocity of that link which is rotating, and on that link our slider is sliding. Oh, this is something new. V omega plus v omega, 2v omega plus r alpha. ये तो पता ही था मुझे आने वाला. I was aware that this is going to come, but that is for pure rotation. But whenever there is a rotation and sliding, some new thing has come. And this new thing we call it as Coriolis component of acceleration. Coriolis component is a small part of tangential acceleration. So we have taken everything in the tangential direction, So Coriolis component will be in the tangential direction. Very good, sirs. In interviews they may be asking why 2. Dekho, please listen. 1 v omega is coming due to velocity of sliding. Dr by dt is sliding velocity. 1v, this is 1 v omega is coming due to velocity of sliding, and other v omega, this is v omega, other v omega is coming due to change in angle. So 1 v omega is coming due to rotation, other v omega is coming due to sliding. So that's why you get the value 2. 2 is due to 2 v omega, 1 v is due to sliding, the other v omega, 1 v omega is due to sliding, other v omega is due to rotation, d theta by dt is due to rotation, dr by dt is due to sliding. That's why you get 2 value. In interviews it was asked why 2 omega. Wonderful, sirs. So this is my Coriolis component of acceleration, 2 v omega, where v is velocity of sliding. I repeat, where v is velocity of sliding, means on the link it is the link which is rotating, on that link it is sliding. If you just observe here, this link is rotating, on that link this is sliding. एक बार देखना, look at this is sliding, and this link is rotating. This is sliding and this is rotating. Look at carefully. Yes. So v is velocity of sliding and omega is the angular velocity of this. Great, sirs. Actually, acceleration, you know, it's a vector. Actually, it is like this. 2 omega cross v. It is a vector. So it is a cross product of omega and v. Great. Ab dekhenge, sirs. Now let us understand certain points carefully. Now I'll show you certain golden points. Let's take a beautiful example. Hope you can see this. Now please observe here. Let us assume that this is actually rotating frame. This is the rotating frame. So I am showing you this is a rotating frame. Let us say it is not rotating. Now the point is sliding. There is no rotation. If it is sliding, purely you have a velocity like, look at, acceleration will be in this direction. If it is just sliding, if it is just no rotation, just sliding, acceleration will be only in this direction. If it is just sliding, so no rotation. If it is just sliding, acceleration will be like this. Now let us see rotation and sliding. Look at, let it rotate. I'm showing you. Let it rotate and this slide. In the rotating frame it is sliding. In the rotating frame it is something like this. Look at carefully. Now first what we did, look at carefully. Now we'll take rotation and sliding. Now you'll see the beauty. Look at, now it is. Now I'm not doing anything. I'm just sliding this pen. It is the slider and this is a rotator. Dekho, I'm just rotating. Look at. Please, एक second, please. I'll take different color so that you can visualize. I'll take different color. Now look at, देखो एक बार. Now I'm just sliding this, देखो, and this is rotating. Oh, see this Coriolis. The deflection is due to this Coriolis acceleration. Let me highlight, my dear students. Look at, now this is rotating. देखो, this is rotating, and this is sliding. Simultaneous sliding and rotation. देखो, I'm just, ये तो सिर्फ मैं स्लाइड कर रहा हूं सर, ये तो सिर्फ एक सेकंड. दिस वन आई एम जस्ट स्लाइडिंग. इधर देखना प्लीज, यू जस्ट सी माय फिंगरप्रिंट. देखो, देखो एक बार, प्लीज लिसन सर. देखो डिफ्लेक्शन, देखो प्लीज लिसन. Yes, this is deflection is due to Coriolis acceleration. Even though it is moving in this direction, because of rotation there is a deflection. Because of rotation and sliding, this is the deflection is due to Coriolis component of acceleration. This is due to Coriolis. Let me explain again. So देखो, pure sliding, no rotation. देखो, no. Let me show you this. Very good, sirs. Very good. Let me show you. So let us say no rotation, pure sliding. देखो, pure sliding, no rotation, pure sliding. Yes. Now let it rotate. देखो, simultaneous rotation and sliding. देखो एक बार. Now it is rotating and sliding. Now देखो, now it is rotating and sliding. देखो, देखो एक बार. Now I'm just, देखो. Yes, this deflection is due to Coriolis. Even though it is sliding, due to rotation and due to Coriolis acceleration, it is deflecting. Hope you have understood. My dear students. Wonderful, my dear students. Now let us see the direction of Coriolis component of acceleration and one more golden point. एक सेकंड रुको. वाह, very happy. Thank you. Look at now. Let us take the Coriolis component of acceleration is given by 2v omega, or it is a cross product of 2 को constant ले लेना, omega cross v. How do I find out the direction? Look at carefully. Please look at carefully. मैं आपको बहुत simple way में बताऊंगा sir. Don't worry. Let's find out the direction. Look at. Now, let us take a link, and this is sliding. Let the sliding velocity be in the upward direction. This is velocity of sliding. And let the link rotate in anti-clockwise direction. Look at, there are 4 situations, sir. So let it slide. Let the sliding velocity be upward, and the link is rotating in anti-clockwise direction. And you know right hand thumb rule. You just take this and see the direction of omega. Look at carefully. So this is rotating. See the direction. It is in the anti-clockwise direction. When it is in the anti-clockwise direction, my thumb is pointing outwards. Means the omega vector is. Look at carefully. Omega is in this direction. Look at carefully. Omega is in this direction. Let us see. So look at, this is rotating. When this is rotating, my omega is in the outward direction. Now let me show you omega. This omega is in the outward direction. 1 second, please. 1 second, please. I have a rod. 1 second. Yeah. Look at. Now this is the direction. Omega is in this direction. Now, how do I find the cross product of? देखो, please listen carefully. Now I want Coriolis acceleration direction. It is the cross product of omega and v. V is in this direction, and omega. So you know what is the direction of omega? It is outwards. So this is outwards. ये outward हो गया. This is the omega direction. This is omega direction, and this is v. Now you know very well, my dear students. Look at, sirs. How do I find the cross product of this and this? इस वेक्टर का कुछ नहीं है. Take right hand and move this vector in the direction of v, in this direction. इसका, ये दोनों का क्रॉस प्रोडक्ट चाहिए. सो फर्स्ट कौन सा है? ओमेगा. तो ओमेगा को v के तरफ ले जाना. लुक एट, कीप द राइट हैंड. आई हैव केप्ट राइट हैंड. नाउ यू मूव दिस. देखो, यू मूव लाइक दिस. Now this is my omega, and you move my right thumb, you move my right hand in the direction. अगर इसका omega और v का cross product चाहिए, ये है देखो. If you want the cross product of omega and v, so you take this omega in the direction of v. So in this direction, देखो, like this. So when I take this, what is the direction? When I take this, my thumb is pointing to the left. So this is the direction of Coriolis component of acceleration. If you know one, the others are very simple. मैं आपको बताऊंगा, फिर से बताऊंगा, sir. Don't worry at all. let it rotate anti-clockwise, let V. So V is in this direction, omega, 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 and the thumb is pointing omega, omega, thumb is pointing outward. This is my omega. This is my omega. This is omega and this is V. I want a cross product of omega and V. V is like this, omega is like this, ये दोनों का. तो कुछ मत करना, राइट हैंड रखना और इसको जिसके रेस्पेक्ट में चाहिए, I want the cross product of ओमेगा क्रॉस V. तो जिसका ओमेगा को इस तरफ ले जाना, you know the concept of vector. तो this one omega you take towards it, तो क्या होगा? When I take towards it, what is the direction of thumb? Look at, I'm taking this towards it. So when I take, the direction is like this. So therefore, my Coriolis component of acceleration, which is the cross product of this omega and this omega and V. So therefore you take, and this will be the direction. So एक आ गया तो बस खत्म. So look at my dear students, अभी तो देखे, the Coriolis direction we got is, this is the velocity of sliding and this is the angular velocity, and you got like this Coriolis acceleration ka direction. Very good, sirs, very good. Now let us, once this is known, rest are simple. Once this is known, rest are very simple. Look at, let us take this and let us take in the clockwise direction. Very simple, sir. अब देखना sir, look at 2V cross omega. Only the direction, देखो V is not changing, V is same. Only omega is changing. So when omega is changing in from anti-clockwise to clockwise, this will become opposite. This will become opposite. Just iska opposite. Just it's something like this. देखो 2 times V cross, this is, I would write minus omega, minus omega, minus omega. So क्या आएगा? Minus means opposite direction. Minus is opposite direction. So therefore V is not changing. If V is also changing, minus of minus will be plus. So therefore it's like this. Now this is the Coriolis component of acceleration. Next, let us assume this to be in this direction and clockwise direction. Look at, please, ये होगा. This is over. This is over. Already over, na? Already over. Now let us take the third case. Let the velocity of sliding be in the downward direction, clockwise direction. देखो, please listen. What is changing? Both with you just see with respect to this. इसको भूल जाओ. You see with respect to this. V opposite. V is minus V. And omega anti-clockwise, clockwise. Matlab, with respect to this, both are negative. Negative of negative will be positive. Positive means same direction. So therefore, it is the same direction. You have not understood. Let me explain. You have not understood. Let me explain. Let me explain. Already you know the first direction. Already you know the first direction. That is anti-clockwise and sliding upwards. This is the Coriolis acceleration. Now I will write upwards clockwise, downwards clockwise, downwards anti-clockwise. Just you see with respect to this, you see, is V same? Yes. 2 omega cross V. Is V same? Yes, V same. Omega is opposite, minus. So minus means what? My vector will be minus. So if plus is like this, minus will be like this. Now here, this is downwards means my V is opposite. So here what is happening? My omega is becoming minus with respect to this. With respect to this, omega is minus. V is same. V को कोई change नहीं. V is same. My omega is anti-clockwise to clockwise. तो ये minus आएगा. Means minus. This is the vector. This is my vector. So with respect to this, my dear students, एक second please. एक second. With respect to this, understand carefully. This is in the anti-clockwise direction and the sliding is in the upward direction. Okay. What is the direction of Coriolis component of acceleration? It is like this. Let us take this. Like this clockwise. What is happening, sirs? What is happening? V is same. Omega is opposite. So 2V omega. If both become negative, negative into negative is positive. Positive means same. If V is downwards and omega is clockwise, it will be same direction. If one is, देखो, V is same, but omega anti-clockwise, omega clockwise, it is opposite. So with respect to this, only one is negative. So therefore, if one is negative, negative into positive is negative. But the complete vector is means answer you got is negative with respect to this. So therefore, it will be like this. Now come here. Come here. Now this is, let us take downwards and let us take anti-clockwise. Look at, sirs. Anti-clockwise, same. It is with respect to this I am taking. Anti-clockwise, same. Omega is not changing. V upward, V downward. V is becoming negative. So negative into positive is negative. This is negative. Means with respect to this, it will be negative like this. Coriolis acceleration. Next, last. Look at. Now, let it move down and clockwise. Down and clockwise. Listen carefully. Now, upward, downward, minus V. And then omega, anti-clockwise, clockwise. Omega is also minus. So what will be this? Now it is plus. Plus means same as this. So it will be like this. These are the directions of Coriolis component of acceleration. Coriolis. So 1 plus, dekho, plus, if you take upward plus, anti-clockwise plus, for example, anti-clockwise plus, clockwise minus. So therefore, with respect to this, you are getting opposite. Well, this is downwards and anti-clockwise. Anti-clockwise, omega is not changing direction, then V is changing in direction, minus. So with respect to this, it will be minus. And here V is negative, with respect to this, omega is also negative. Negative into negative is positive. Positive means same as this. Hope it is clear. Now, let's see one beautiful point, my dear students. So Coriolis component of acceleration is 2v omega. It comes only when there is a simultaneous sliding and rotation. Now what we do is, let us weld this. इसको weld करेंगे. Let us weld this and just it rotate. What is the velocity of sliding? So when I am welding this, it is not sliding. When it is not sliding, only omega is there. When only omega is there, velocity of sliding is 0. When velocity of sliding is 0, my Coriolis component of acceleration is 0. So Coriolis component will become 0 when one of the values becomes 0. What is that? Either velocity of sliding is 0, if there is no sliding, and if there is no rotation. Let us say omega is 0. If omega is 0 and there is pure sliding, let us say, let us fix it. It's not rotating. It's purely sliding. When it is purely sliding, omega is 0. When omega is 0, again Coriolis is 0. Coriolis component will come only when there is a simultaneous rotation and sliding. So if sliding is 0, V is 0, Coriolis is 0. If rotation is 0, omega is 0, Coriolis is 0. Now let us see the last part and you are going to enjoy, and with this model I'll explain now. Please listen, sirs. Please listen. You might have seen crankcase slotted lever mechanism. देखो एक बार. This is the crank, this is the lever, and the lever is oscillating. And please observe, my dear students, let me give you the beauty here. And you have seen that, and you have seen very clearly when this becomes tangent. For example, when this becomes tangent, so this is the extreme position. Now in this we have seen in case of cutting and return stroke. So this is one extreme position, and this is another extreme position. This is another extreme position, and this is the extreme position. This is the one stroke, end of one stroke. This is the end of other stroke. Now these are the extreme positions. I will show you what are the extreme positions. Just observe here. You will appreciate. Just observe here. It is at the end of the stroke, and this is tangent. Now please see the direction of this. Please see the direction. Now look at carefully. Now it is forward. See the rotation of this. It is clockwise, and this is forward stroke. This is clockwise. Look at blue link slotted this link clockwise. And once it reaches extreme position, now this is coming back from clockwise to anti-clockwise. Means when will this become clockwise to anti-clockwise? Omega is becoming clockwise to anti-clockwise. When it becomes, so means at some position it should be 0. It means, dear students, at this position, actually it was moving in the clockwise direction. See this clearly. Clearly. A second, I'll show you. There are so many complications, but yet I'm trying for you. Look at. Don't worry, sirs. Don't worry. Ho gaya. Yes, it is in the forward motion. This is in the forward stroke, and this blue link is in clockwise direction. Dekho, clockwise. Once it becomes tangent to this circle, once this link becomes tangent to this circle ko tangent. Now this is the extreme position. So now it is reversing. Originally it was clockwise. Now it is reversing. Means At this position, my omega is reversing the direction. Originally it was clockwise, now it is becoming anti-clockwise. Means, how can you move from positive to negative? You can move from 3, 2, 1, 0, -1. So positive to negative means 0. So it is clockwise, 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 clockwise. Now it is, dekho, now this is sliding and rotating, sliding and rotating. Whenever there is sliding and rotating, there is a Coriolis component of acceleration. But at the extreme position, now omega is changing direction, means omega is 0. As omega is 0, at this extreme position of the stroke, the omega value is 0, Coriolis component is 0. Similarly, now you just see my dear students. Look at, ye forward ho gaya, dekho, now it is coming back. Now anti-clockwise, 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 anti-clockwise. Please listen carefully. Now anti-clockwise, and this is at the extreme left. Look at, let me show you. Let me show you very clearly. Dekho, it is clockwise, 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 clockwise. Now omega is 0 at this position. Now it is reversing. Anti-clockwise, 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 anti-clockwise. Again extreme position, omega is 0, because anti-clockwise to again clockwise. Anti-clockwise 0, anti-clockwise 0, again clockwise, means omega is 0 again here, means the Coriolis component is 0 at the extreme positions. At the extreme positions of the stroke, Coriolis component is 0 because omega is 0. Omega is 0. And similarly, one more point, sir. One more point. Now look at carefully. The slider is moving upwards. Look at, the slider is moving upward. It was at this radius. Now what is the radius? Increase. So what is the radius? Increase. What is the radius? Increase. So it is becoming maximum radius. So radially increasing, increasing, increasing. Look at, please see the position. So what is the radius? What is the radius? Very less. Now what is the radius? Large. What is the radius? Large. What is the radius? Large. So it is becoming maximum and then again decreasing. Means dr by dt. What is dr by dt? The velocity of sliding is dr by dt. Means now you are look at sirs. Now radius is increasing. So originally it was here less radius. Radius is increasing, maximum, and then it is decreasing. So radius is increasing, the sliding velocity is increasing, and here it is becoming what? 0. Why it is 0? देखो एक बार, radius increase होके अब decrease हो रहा है. How can it? देखो, radius is decreasing. Now increasing. So it is increasing and decreasing. Means at some position it should be 0. At some position, therefore, at the top position, the velocity of sliding is 0. At this position, it cannot move. देखो, it is increasing. With respect to this, it is increasing. Again, it is here. It is increasing. देखो, radius compared to this radius is more. Compared to this radius maximum reach होगा. अब now it is decreasing. So increasing and decreasing means increase to decrease means it should be increase to decrease means it should be 0. So here the velocity of sliding is 0. It cannot move up. Now it is moving downward. Again upward. Downward means the sliding velocity is 0 here. The sliding velocity is 0. Let me repeat, sirs. The slider is here, and after some time the slider is here. So the radius is increasing. Again, it is reaching maximum here. After reaching maximum, it is decreasing. Again, it is decreasing. And here it is the minimum, and then it is increasing. So up to this increasing, decreasing. So therefore here the velocity of sliding is 0. So therefore in crank and slotted lever mechanism, at these two positions, as the sliding velocity is 0, therefore Coriolis component of acceleration is 0. At these two positions, the omega is 0. That's why the Coriolis component of acceleration is 0. Hope you have understood, my dear students. Thank you, my dear students. All the best. We'll come up with some more videos. Thank you.